Hi everybody, I'm Greg Fishel. Welcome to bonus weather video number 1 for this week, and we're going to be talking about something called the Isallobaric wind. Now, you've all heard of isobars, which are lines of equal pressure, but isallobars are lines of equal pressure change, and they actually can have much more of an effect in terms of making the wind extreme than just the isobars themselves. So that's what we're going to be talking about today. So let me put myself down in the corner and we're going to start off with just a little bit of review here. Now, if everything was balanced in the atmosphere, the weather would be very, very boring, okay? Really, our weather comes about as a result of imbalances going on, and certainly what we're talking about today is an example of that. But the balanced flow is what we call the geostrophic wind, and basically, if you have an area of high pressure with a clockwise flow in the northern hemisphere, then you have the pressure gradient force, which is directed from high pressure to low pressure. So that's actually moving away from the high. And that balances with the Coriolis force, which is caused by the Earth's rotation, which moves everything to the right, okay? And so in the northern hemisphere. So as a result of that, those forces balance and the winds basically go around the high in a clockwise manner. Friction will tend to make the wind go just slightly across the isobars toward lower pressure, but by and large, it is a clockwise and balanced flow. Okay, so with a unbalanced flow, instead of calling that the geostrophic wind, we call that the ageostrophic wind. And so we've got pressure rises and pressure falls here. So we've got an area of high pressure here, an area of low pressure here. The pressures are falling ahead of the low and they're rising ahead of the high. So these dotted lines that you see here are called isallobars. They are lines of equal pressure change, and the stronger the gradient or difference that you have in those values of the isallobars, it's much like isobars. The stronger the gradient, the stronger the influence is going to be. So we have pressure rises there, we have pressure falls here, and as a result, the wind blows from the biggest pressure rises to the biggest pressure falls. And so you end up getting a wind like this. And in these types of situations, the winds will cross the isobars at a much, much more severe angle than they will if the flow is fairly balanced. So if you have a big storm that is rapidly intensifying, you tend to get these couplets of pressure rises and pressure falls, and it greatly influences the wind and causes accelerations to occur and for the wind to be much stronger than it would be otherwise. So isobars are lines of equal pressure. Isallobars are lines of equal pressure change. So let's take a look now at a forecast for 4 a.m. tomorrow morning. And I know that there's so many lines here, the geography sort of gets lost, but North Carolina is right in here, okay? This is an area of low pressure, which is rapidly intensifying over south central Virginia. And the pink colors here, or purple, I guess, represent big, big pressure falls ahead of the low. And then these areas back in here, when right in the middle of it, I've got a little light blue there, are big pressure rises going on behind the storm, okay? So as a result, the strongest gradient of isallobars, or pressure changes, actually runs from eastern Kentucky and northeastern Tennessee across Virginia over toward the Delmarva Peninsula. Now, Raleigh is about in here, so we're just outside of that tightest gradient, but we've still got a decent gradient. As you can see here, we go from dark green to light green to lighter green to lighter green, and then yellow to orange to red and so forth. So yes, the strongest forcing is up in here, but what's going on in the Raleigh area is not too shabby either, okay? And so you have to wait until the pressure rise center actually gets over you or near you for this effect to go away. So if you're in between the biggest pressure rise to the biggest pressure fall, then you are going to have a greatly accentuated wind speed. and those winds are also going to cross the isobars at a much, much more severe angle. So this is why we think that the winds could gust to 30, 35, and 40 miles per hour late tonight into the first part of tomorrow until the pressure rise center gets on by us, and then the wind should lessen up quite a bit later tomorrow and tomorrow night. I hope that makes a little bit of sense. So that is bonus weather video number 1 for today. The next one, number 2, will be coming up on Wednesday. And of course, the next daily weather update will be coming up tomorrow. So you all have a great rest of your night, and hold on to your hat on your way to work or school tomorrow morning. And we'll talk to you again tomorrow afternoon. See you later, everybody.